Now let us discuss about the case study of signals in communication systems. See, what is mean by signal means it is which contain some information, that is called as your signal. It is of your continuous time signal and discrete time signal. That is nothing but analog signal and digital signals. See, analog continuous time signals are continuous in amplitude and continuous in time. Digital signals are continuous in amplitude and discrete in time, right? In this way, we are going to segregate your different types of signals, that is nothing but symmetric and anti-symmetric signals, deterministic and random signals. See, based on this communication only, we are going to define your deterministic signal and random signal. See, deterministic signal means it can be completely represented by mathematical equation. For example, sine wave, cosine wave, etc. Random signal means which cannot be completely represented by mathematical equations called as random signal. That's why we are going to see about the different types of signals in communication systems. In this case study, we are going to see about the how the signals communicated in your systems like multi-rate signal processing, adaptive signal processing, etc.
Here it is an introduction of signals. In the domain of electrical and communication engineering, the signal system is their role in conveying information in the variations of time, whether it is a voice in the phone calls and a video live in the video streams and sensor outputs in the IoT devices. And they are represented through the mathematical and physical sensors and signals. Here is many ways in engineering through the department, through the biomedical and the electrical and research department. And the essential properties is through an reboost of some of smart sensors in the
Types of signals. Types of signals, we are going to see about different types of signals. And first one is analog signal. Analog signal is continuous in time and amplitude, where analog signal is represented by the sine waves. And for example, we can take the radio television system and like that, etc. And second one is the discrete signal or digital signal. Digital signals are naturally discrete in nature, and it is also converted in both time and amplitude, and they are represented by zeros and ones. They can call it as binary sequence. And last one is deterministic and random signals. Deterministic are as said, it is predictable, where we can predict what will be the value or result. And in random signals, it is unpredictable because of them. Their behavior, different behavior it has.
Next one, how the signal processed in terms of communication systems. It is of wired communication or wireless communication. That is means wireless means we can use it as your satellite communication, radio broadcasting, etc. Wired communication means we are using it as your optical fiber cables, some type of cables are. See, different types of modulation are available in your communication systems are amplitude modulation, frequency modulation, phase modulation. See, amplitude modulation means we can information signal can be varying with the help of carrier signal in accordance with your message signal. That is nothing but your with respect to amplitude. That is nothing but your amplitude modulation. See, in this different types of modulation, we are going to predict the signals in terms of communication systems.
Okay, yes. As Sir said, we have types of signal transmission. Like transmission is basically passing a signal from a source to the destination. The quality of the signal depends on the medium which is used and the environment. Like first coming to the wired transmissions, like fiber optic cables, Ethernet cables, and the coaxial cables, which are maybe low susceptibility but gives a high bandwidth. They may be costly and less flexible. And moving to the wired like Bluetooth, Wi-Fi, mobile networks, 3G, 4G, and 5G. Wireless transmissions are scalable and gives high mobility. And similarly, in both also impairment of signals takes place, like noise, signal fading, multiple signals through the channels, etc.
Okay, and now let's have a look at some design approaches and optimization techniques in designing circuit. First, we have the conventional CMOS circuit. This method uses around 28 transistors to implement a basic logic gates, and it's more reliable. But the drawback, it takes up more space and consumes more power, in which isn't ideal for today's compact and power efficient devices. So to tackle this, we use low optimization technique, like pass transmission input, which reduces the number of transistors and area needed, and gate transmission input, which helps to helps for signal strong signal transformation and low power usage, and gate diffusion input, which is a modern technique that cut down the power and delay and complexity. And even in some cases the hybrid approaches are used, which is combination of combining these styles to get a best balance of speed, power and the size. For example, an full optimized full adder can be just made using 10 to 14 transistors, even though it still work with the accuracy and with more power saving.
Now, applications of communication systems. Now, the analog and digital converters may be transmitted into signal handling. So, its voice and radio waves are increase the antennas and transmitted into the analog digital encoding and decoding. So, both are protect and applied with the transmissions of the decoding and encoding of the radio waves. So, it will be continuous and discontinue with the being perfect of this transmissions and speeds and distance.
Now we can going to discuss how these signals are communicated, means in terms of IAR filters and FIR filters also. See, IAR filter means by considering only the infinite samples of impulse response. FIR means by only considering the finite samples of impulse response. Also, in addition to that, we are using it as your adaptive signal processing and multi-rate signal processing also. In terms of multi-rate signal processing, we are analyzing the upsampling and downsampling process, and adaptive signals also by using least mean square algorithm. We are going to segregate with the help of transmitter how the signal is encoded and decoded, and how to get the received signal with the help of band pass signals, right? How the way signals can be processed in terms of communication systems.
I would like to conclude this case study review. I would like to highlight that the signal cannot be used as mathematically. It can be used as lifetime in electronic items like phones, computers, whatever, but it can be used as lifetime. And then especially like voice signal or processing principle, and it can be all applied in the industry, which is useful for us. And as he said, Bluetooth connection and wired or wireless connection, comparing wireless connection is better. It can be connected through long distance. It is very priceless. It is useful for us.
Thank you all.
Thank
Thank you,
sir.
sir.